Have you ever just stopped and wondered how those massive, incredibly complex apps on your phone just work? I mean, without constantly crashing? Well, today we're going to peel back the curtain and look at the absolute fundamental building blocks that keep our entire digital world from collapsing into chaos. All right, let's jump right in. And we're going to start with a bit of a strange question. What on earth does a frantic, website crashing, pull your hair out disaster over concert tickets have to do with writing good, clean code? Well, stick with me, because the answer is pretty much everything.
So, first up, let's set the scene. See, before you can really appreciate good, solid structure, you have to understand the alternative. You have to see what happens when there's none. We need to talk about code, chaos, and the crashes that always follow.
I want you to picture this. Your favorite band just announced their reunion tour. Tickets go on sale at 10 a.m. sharp. You're there, you're ready, you're hitting refresh, and then nothing. The site freezes. It slows to a crawl. You get some bizarre error message. For you, it's just super frustrating. But on the other side of that screen, it's a full-blown technical meltdown.
So, what's actually going on behind the scenes? Well, when thousands of people all hit buy at the exact same second, different parts of the code are all trying to access the same little pool of data. We call these global variables. It's a total free-for-all. It's like two people trying to edit the same sentence in a document at the same time. One person's change overwrites the other's. In programming, this is called a race condition, and it's a nightmare. The system gets confused, it starts showing the wrong number of tickets, it oversells seats, and eventually, it just gives up, and the whole thing comes crashing down.
That chaos? That is precisely what good programmers work so hard to prevent. And they do it by building things with order and purpose, starting with the absolute basics, knowing the crucial difference between a function and a procedure. At its heart, the difference is actually really simple. A function's main job is to produce a piece of information and hand it back to you. It returns a value. A procedure, on the other hand, is all about performing a task. It just does something. It doesn't give you anything back. Let's make that a bit more real. Think of a function as a tiny, specialized calculator. You feed it a number, say the price of a t-shirt, and you tell it, hey, calculate HST. It does its little bit of math, and what does it do? It returns one single useful piece of information, the exact tax amount. It gives you a value you can now use somewhere else. Now, a procedure is more like a set of instructions for an action. Imagine you have a little robot that knows how to draw. You just tell it, draw a square, it follows the steps, move forward, turn right, move forward, turn right, and so on. When it's done, you've got a square on your screen. It performed a task, but it didn't hand you back a number or a piece of text, it just did the thing. You know, I love this analogy from Simon Lumb at the BBC because it just makes so much sense. Making dinner is one big project, right? But you don't think of it that way. You naturally break it down into smaller, manageable chunks. You prep, then you cook, then you eat, then you clean. Each of those is its own little self-contained set of instructions, and that separation makes the whole thing doable instead of just one overwhelming mess. Okay, so if functions and procedures are like individual recipes, where do you keep them all organized? Well, that brings us to the next level up in our organization chart, modules, which are basically the programmer's toolbox. Let's go back to analogies. You wouldn't write a textbook as one giant endless wall of words, right? You organize it. You have paragraphs that make a single point. And then you group related paragraphs into chapters. It's the exact same idea in coding. Functions are your paragraphs, and modules are the chapters that group all the related functions together. So the key idea here is that a module is a specialized toolbox. You might have one toolbox for everything related to handling payments, another toolbox for all the user account stuff, logging in, changing passwords, and a third for all the graphics. Everything has its own proper place. And here is why that is so incredibly powerful. Let's say you're coding a simple dice game. You need a random number between 1 and 6. Now, you could spend hours trying to write some complex mathematical algorithm for true randomness, or you could just grab the random toolbox that some genius has already built and perfected. In a language like Python, you just write import random, and bam, you instantly have access to all its tools, including a super handy function called randond. It is the ultimate form of not reinventing the wheel. Okay, but how do these neat little boxes of code know what to do specifically? You don't always want to roll a 6-sided die. Maybe you need a 20-sided one. Well, that's where the mechanics of passing in the details come into play. It's really just a simple handoff. First, when you build the procedure, you define it with a placeholder. You tell it, hey, expect to receive a piece of information and we'll call it sides. That placeholder is the parameter. Then, later on, when you actually want to use it, you call the procedure and you hand it the real value, like the number 12. That real value you pass in, that's the argument. Simple as that. Now, this idea leads to one of the most important concepts for preventing that chaos we talked about. It's called scope. Scope basically just defines where a variable, a piece of information, is allowed to live in a program. Think about it like this. The ingredients for the cake you're baking belong in your kitchen. You don't just leave the eggs in the living room and the flour in the garage where someone else might trip over them or use them for something else. And this is the critical difference. A local variable lives and dies inside one single function. It's created when the function starts, and it vanishes into thin air the second the function is done. It's safe, it's clean. A global variable, on the other hand, lives everywhere. Any part of the program, at any time, can see it, and this is the dangerous part, can change it. That is exactly the kind of tangled mess that caused our ticketing website to crash and burn. So let's bring this all full circle. We've seen the chaos, and we've learned about the tools of order. Now, let's see how we can use these tools to transform that initial disaster into clean, reliable, working code. We are going back to that moment of pure panic when the ticketing site was on fire, except this time we are armed with functions, modules, and a deep respect for scope. So here's the fix. That problem of tangled global variables, we solve it using modules. We put the payment system in one box and the ticket inventory in a totally separate box. They can't mess with each other. Those data conflicts, we solve them by keeping our variables local. The function that checks ticket availability only has access to the data it absolutely needs and nothing else. The whole system becomes predictable, stable, and reliable. And look, this isn't just some theory. This is how the modern world is actually built. When you load up a show on BBC iPlayer, there are separate little functions all firing off at once. One to get the images, another to get the text, a third to stream the video. On your banking app, the payment modules are kept completely separate and secure from the parts of the app that just track user analytics. And in huge video games, the physics engine doesn't know or care what the audio engine is doing. They live in different worlds, in different modules. So at the end of the day, these ideas, functions, procedures, modules, scope, they're not just academic concepts for a computer science exam. They are the absolute bedrock, the fundamental rules for building the kind of reliable, powerful, and scalable software that we all depend on every single day. So I'll leave you with a little challenge. The next time you use an app, any app at all, take just a second and try to imagine the elegant, invisible dance that's happening behind the screen. An entire orchestra of tiny, well-organized functions and modules, all working together in perfect harmony, just to make it all seem effortless. Can you picture it?